Hi and welcome back to the lab. And today here on the bench we have an ICOM IC-705, and the 705 only allows battery operation. So you cannot connect it to an external power supply, or you can't connect a bigger battery to the unit, so that does the IC-705 not allow. So then, additional to that, we cannot charge our internal battery. So something is really wrong here, and let's see what's going on. So let's see what we have. So let me switch it on, and it's coming up, and yes, very nice. So it is working, and it is working on our battery, so there is no connection to it, and the battery itself is completely charged, so no problem, and we have nothing external connected. So now let's connect it to the external power supply. Okay, so everything is prepared. So we have 13.6 volt here connected to our radio, and now let's switch it on. What we have now, and we see that we have a very little current flow here on the display, but that might be related to the fully charged battery, so that is nothing we can judge right now. But what we can do, we can switch it off, we can switch the radio off, and we can disconnect our cable. Then we take off the internal battery, and now let's see if something is happening now. Let me see what happens. Let's try. And no. So you see, I mean, there is very little current flow, okay, but well, I cannot switch the radio on. So therefore, okay, something is wrong. We have to clear if also our charging function is faulty, but that is then second what we do. Now we directly see that we cannot switch it on, and there is not a huge reaction here on the power supply when I press here my power button, so nothing at all. That means let's crack open the radio. Well, basically we only have here some screws which we need to take out, and then we can pull off here our user panel, so that is so far quite easy. Okay, so the screws are out, so now it is very easy to pull here the front panel off from the radio, and what we directly see, we have two ribbon cables here connecting the main unit with the front unit, and therefore of course we have to disconnect this both connections. So you have to be very carefully to do this here, and but that is already everything we need to do to get our display or front panel off. And now what we see here under the shield is the main unit, and unfortunately we have really to dig inside simply because our charging regulator and what have we is on the PA unit, and the PA unit is the PCB which is really on the bottom here of our housing. So therefore we really have to take everything off, and then, well, let's see what we find. So first what we do here is we have to take off the shield, and therefore we need to disconnect another little ribbon cable here. So that is something we really need to do. And then you see we have to lift here our shield, which is a little bit holding here by the clamps, and finally a last screw which I have not taken off, but now we should be able to take it away, and that is what was necessary to do. Now, you see, we have here our main board. By the way, we have here our Wi-Fi board. Well, now we really have to take everything away here and have to go deeper into our radio. And after I have loosened this both little antenna wires here, we can lift the board a little bit, and we can take this ribbon cable away from here, and you see we have taken it out. Now we see another shield, and of course we need to go deeper. And here on the side we have this little connection PCB, and we gonna change this connector later with a newer version. This newer version does have, let me show it to you, does have a USB-C connector, which is something the owner wishes to get this little board instead of the original, because the original has an older USB version inside. So therefore that is something we're gonna change within the process we have anyway to do here, and therefore, yeah, let me do the next step. Okay, so the 3 screws are off, and what we can easily see, so that is the board. So we need the little ribbon wire here for the new board, and that is what we change out when we put it back together. Now for the next step, obviously we have to loosen this little black screws which we have here on the shield, and then we should be able to get here our shield away. So the little screws are out, and now we can lift here the middle chassis part, however, to get deeper here into our unit. And what we need to do next, so we, of course, you see we have here our filter board, and on the right hand side we have our RF unit, and we need to take our RF unit out in order to get deeper to our PA board, and maybe then we can already see our charging unit. So that is the next we have to do. Okay, so I've lifted it already a little bit, but it is important to get our shield here away, because you may see that we have here a couple of little RF wires, and of course in order to get it completely out we need to lift here on our board, and now I can finally take off all these connections in order, yeah, to have here a free view and access to the charging electronic. And again we have here another screen, so that is something of course we need to take away as well. And now what we see down here, so under this shield we have the main electronic for charging and controlling the battery charging at least. And of course we have here some components down in the circuit which are responsible to switch between battery and our external source. So if we are lucky, we have a problem down here in our logic. If not, the problem is under this shield, because we have down here a big integrated circuit underneath, and I hope that we do not have a problem down there, but that is where we really now need to go into testing. Okay, so what you see here is that I've taken off the shield here, and well, yes, we can see the IC over there, and well, I have everything prepared so that we can start testing. Of course, what we already know is that with the battery attached we can of course switch our unit on, even that we do not have connect our RF board to the circuit, because here this is not needed for the moment. But well, so that is what we know, and the next step is we connect here our DC cable to the radio to see if there is something different. Again, with the battery attached only, so we only see here our battery voltage. And now let me try to connect our cable. And that is now what we can see here. So we can see here on the display that there is something external, and you see that the voltage here somehow is bouncing back and forth a little bit. 8.3, don't know if you really can see it, but something now 9.5 and back and forth, and something really seems to be a little bit odd here, and therefore that is definitely the first where we need to look after what is really going on. And as you can see, the next step is that I've taken off here our battery, our pack, and the radio is only attached to our power supply, but no battery any longer. And again, when I now try to switch here our radio on, so that is the known behavior, so we have no switch on activity. And that is what I meant when I said, okay, that is the first what we need to investigate. Okay, so time to analyze a little bit what's going on here. This here is finally our controlling circuit when we get our 13.8 volt connected by, for example, an external power supply, how we are using it here. And now when we go here a little bit more into detail, I hope that you can see it good enough. Then we see here right from the beginning that we have here a coil, so that is a EMI coil, and then it goes here to our first Q1, which is finally a MOSFET, and that is for reverse voltage connection or protection for reverse connect, right? And then you see that we have here IC1. IC1 is nothing else but an overvoltage detection, and if an overvoltage is detected, our second MOSFET get switched off in order to protect the whole radio. And when we go along, we see right after the voltage has passed here through our Q4, then the voltage there gets directly connected here over our AP7, the D51 diode, over to delivering so-called HV voltage to the whole radio. Additional to that, there is a second voltage which is called VCC. VCC is the second question. The first is our HV, so the high voltage which should be deliver the voltage to the entire radio. And that means that we should finally get here over our input connectors, so right here, our 13.8 volt through our two MOSFET transistors, maybe with a little drop, but not much. So we should get it over right here to our high voltage. We can test the high voltage, let's say here at pin 8 or pin 1 at our Q4, and that is really the first what we want to do. When we look here on our board layout, we find, not sure if you can see it, let me enlarge it here a little bit. So here, that is where our voltage comes in. We have here our EMI filter, and you see here our Q1 transistor. So that is a reverse connect protect, and then we have here our Q4, which is our over voltage protection, together here with Q3 and some other components as well. But our Q4, that should be our MOSFET, where we should be able to read our 13.6 volt, which is finally our high voltage supply. Of course, it goes over some more components because as I already told you, we have here an IC under the shielding, which we have taken off, right? There is here our IC2. IC2 is the charging controller circuit, if you like, for our battery, of course. And we have here some more MOSFET components, which are, involved in switching between a battery and a DC power supply, or even a bigger battery, whatever you take into the field. So therefore, controlling, switching, and so forth, that is what all these components do. But what we definitely can test first is our high volt on HV contact, so we can directly test it here on Q4. And there should be, if we feed, let's say, and you see what we had here on our manual, so you see 13.8 volt. So let us feed 13.8 volt, and then we should be reading something around minimum. Let me say minimum, we should see something around 13, but I think it is even more what we should see here. So let's start from there. Okay, to have a little bit orientation here on the board, even you see we have here some heavy reflections, so that is our input port here, okay? But I just want to show you where the components are which we need to test. So we have here, so this component is our AMI component, so that is FT1. Then we have down here this little component really down there. That is our transistor, our MOSFET transistor Q1. So that is the little guy here. And then you see here another MOSFET, and that is our Q4. And as I said, we should be able to read here at our Q4, we should be able to read when we feed 13.8 what we do. We should be able to read here at the Q4, let me say minimum 13 volt, but it is 13.5, I would say, because we have two MOSFETs in between, which has a relative low drop. Let's say 13. Anyways, that is a minimum we should see. And now I'm now curious if we really can see that voltage down here at Q4. Okay, so let's try if we can take the needed measurements. So we start here at our AMI filter, right at the capacitor, which is set here between plus and minus. And there you can see, yes, we have our 13.8 volt more or less. And at the input we have our 13.7, so that is input AMI filter. I'm now, as we discussed it, I'm now interested what at Q4 what the voltage will be at the, let me call it, output side of our MOSFET, which is, let me see if I can really see it here. Hang on a second. Okay, so let me try to go down here. That is not very easy because I really can't see the little contacts here. But we want to see if we have here minimum of 13 volt. Look here. So that is something I already thought. We do get here a reduced voltage, only a 9 volt. And what you see as well on the graph, that the voltage is not really constant. It is going up and down a little bit, so that is definitely not normal. So that should be really relatively constant, okay? So that is already a problem. So that means we need to go more to the input, and we again start here at our AMI or RFI filter, so we have different names for it. Again, at the input we have our 13.7, which is normal. So now let me go to the output, which is here. What do we look here? So, and that is definitely already not normal. So that is a filter, more or less. It is
a coil which should reduce. And look here, so there the voltage is coming up, which is already not normal. Look here, so that is funny. So it is only a coil at least which should have a very, very low resistance. And what we see, we have already more than 4 volt, 4.8 volt, if you like, drop here at our RFI filter, which is not normal. There is something wrong. So the RFI or AMI filter, so we have here the negative side, and on the other is the positive side. So that means positive 13.8 volt, and here we have simply our ground. And that means if I go, let me set it here to ohm. And now let me go and test here. So that is negative, and on the negative side, do I get the contact? Yes, so 0.1 of an ohm, so that is normal for the coil inside. When we go now to the positive side, so where positive voltage is connected to, look here, so we have 4.8 kilo ohm, which is definitely wrong. So we have here on the positive side, we have a voltage drop. So that indicates that the RFI filter is not really working fine. So look here, we have our data sheet here for our, and you can directly see it here. It is a SMD EMI filter, which is for reducing the noise which might come from a switching power mode supply. So therefore directly at the input where the voltage comes in, we have this EMI filter, which makes sense. And I have checked the type, and the type number is the DLM 0102, which is a 25 volt type, and the rated current is 3.5 amps, which all makes sense. And here you can see what I already explained. So down here, let me see where I have my pointer here. So look here. So we have definitely a coil from 1 to 4, and we have another coil from 2 to 3, which is simply the coil what we should be able to test. And we have seen on the negative side in our circuit, we had 0.1 of an ohm, which is normal. And on the other line, we had, what was it? 3.5 kilo ohm something. And that looks like that for a reason a higher resistor has built out. So that might have happened because of a short inside our circuit, or it was overheated, or I don't know. Maybe that somebody tried to increase the output power, which would then subsequently increase the needed current, so that the 3.5 amps, which was indicated here for our component, was and the current what the unit would take if somebody has, for instance, increased the output power for then maybe more than only 3.5 amps was drawn, and then over the time the coil, or maybe two, goes bad. So that could be a reason. But on the other hand, as I said, another component which is here in the signal path can be broken as well. And look here you can see the inversion loss. So that is here in megahertz. So here is 1 megahertz, and here is 100 kilohertz. And you see in this area we have the highest inversion loss, so there a lot of noise gets simply reduced, and that is what this filter is simply doing. Okay, that means we really need to think how we go ahead. We know that something is wrong here with the filter, and as I said, maybe some other components behind the filter could be the reason as well, but maybe that the unit has been dropped, so that could be a potential risk as well, to have here a break inside the coil. So a lot of different reasons could happen here, and we need to find out a little bit what was going on. maybe we really need to take the filter out, and that for itself is a funny task. Okay, so under the microscope I have checked if I can see or find some burnt components within our circuit here, but everything looks fine, so there are no burning marks here on the top side. There are some components which belongs here to this charging and controlling circuit, so maybe there is something. I can't see anything here, but to get here our component out, so our EMI filter, you see we have here critical plastic connectors nearby, and yeah, everything is close together here, so very narrow space. So it is definitely not easy to get it out, because we need hot air to lift the component, and therefore I think we really have to take it more apart. So we need to take out here our filter board, and then at least we need to take out the PA board. Then we can invest our backside of the PA board, and then we need to think what or how to do it next. I mean, the radio itself is out of warranty, so that means if it would have been warranty, in this case it is always a good idea to simply change the whole board, but that is not given here. So in the worst case, even it is not warranty, we have to change the whole board. But well, for the moment we try to go on component level repair, but well, it is not finally decided yet. So the PCB is out, underneath everything is fine, no problem whatsoever. So that means now I start to cover here our plastic components in order that we can work with hot air. Okay, and as you can see, our component is out, so our pads are all fine, so no problem. And that means now we can go ahead. So, okay, look here. So that is the cracked open EMI filter, and what you see are here the both coils. So for the positive and the negative voltage, or not the negative, the ground and the positive. And what you may see as well is that this down here, let me see if I can point it, this down here, so that is the good one. So we have good continuity, and here the upper one, there we do not have continuity, or what we have seen, it was 4 k ohm something, 3.8 k ohm. And well, so why is that so? If we look here, when we look here, let me try to get it a bit more in focus. So look here, this is a connection from here to this pad, and we have here exactly the same. Look here, so you see that it is burnt out here. Here it is fine, here it is fine, and here it is burnt out. This here in the middle, so that is plastic, that is not, that has nothing to do with the fold, so that is more when I cracked it open. But you see here that the solder joint here is dark as well. I hope that I can now get it away here, so that is not so easy. Let me try. So the little coil which is what you see here upside, so that is already loose. And when I now take it away, so you can see exactly that on this side it is burnt, whereby here on the left side the solder joint is just fine. So let me try if I can turn it around a little bit. Let me see, can I turn it somehow? Because there we can see exactly the same. So is it sharp enough? I don't know if we can get it any better. So it's a little bit tricky, but what I just wanted to show you is that this side here, which was connected to the good pad, is fine. On the other pad, or the other joint here, you see that is burnt. And the question now is, what happened here? I mean, the EMI filter itself is rated for 3.5 amps. And, you know, if we calculate 10 watt output power, so we have an efficiency of, let me say, 50%. So let us assume if we have a TX output power of 10 watt, we have approximately 20 watt the amplifier consumes. So under that condition, and with 13.8 volt input power, the radio would consume 1.44 amps. So under that condition, so under specified conditions, I do not see a reason why this burning here should happen, because I cannot find another short in the radio. So there is no short, and that looks that it happens very, very slowly. And I could imagine that maybe, you know, the amplifier in the radio can handle 30 watt. And if somebody has changed something in the setting and the radio would really go for 30 watt, what the amplifier transistor itself could handle, then we are far out of spec. And then I could imagine that, you know, if then the guy who is using this radio is talking on FM for a very long time with a higher current consumption due to a higher TX output, then that could get over the time hot, and maybe it would start melting, and you know, then that is something what could happening. And I believe that the whole picture looks a little bit like this. There was not, you know, a dead short, because then maybe this little coil simply would have gone open, because, you know, we have seen it, it is 0.1 of an ohm, and a dead short might kill it, and therefore, okay, that could be a reason if we have a dead short. But this here, you see, even here, it was definitely no dead short, and our fuses in the supply line wasn't broken. So, you know, we did not have a dead short. But this here really looks like that is slowly burned out until, you know, the time when the resistor was going up, and then it was not working over, you know, our normal power supply wiring. So that could be one reason. I could only assume it. We are not sure that that is really the fact, but maybe. Of course, our next step is to replace our EMI filter, and that is a little part here which we have here. So you see that here is our new filter, and that is of course an SMD component which we need now to fit into our circuit. Just that you get an idea what we are talking about when we say EMI filter. So that is basically what we have in our circuit. So that is a little component we need to replace. And simply you see we have two capacitors and two filters, if you like. More important is here our diagram where you can see how it works. So look here. So that is 0.01 megahertz. So that means we have here 10 kilohertz already with our first vertical line, and you see if we have the deal M01, that already at 10 kilohertz we have attenuation of 10 dB, and you can see at 1 or better 2 and 3 megahertz, so you see we have more than 90 dB attenuation, and that means that this filter is really able to filter many noise out, especially when we have, let's say, an SMPT power supply connected to it, but it is more than only that. So that is a very efficient part in our circuit. Okay, so as you can see, our new filter is in. So everything is nice and fine. So that means now we really have to put all back together, and then this radio should be fixed. Some additional hints. So we put, as you can see now, our PCB back here into the housing, and it is essential that you really
use a torque screwdriver, because we have here, for especially the shielding here, we need to put 0.7 Newton meter to the screws, and therefore all the screws we are really putting in and bringing back gets put into the right torque of 0.7, as you can see. So that is definitely essential. As you can see, the puzzle is more or less back. So the last what we have to do is here our connect unit. So on the left hand side, this here is the original one, and this is here PCB from outside, so that means that is not ICOM. But the advantage is we have here a C connector, which we have here in the original one not. And so that is what the owner wanted me to put in. So everything is, other than that, the C connector here, other than that, everything is exactly the same. So we put now this back into the radio to have finally a C USB connector. And as you can see, the modified connect board here fits perfectly in the 705, so no problem whatsoever from the mechanical side. And for all of you who may interested in who is delivering this part, so that is, as you can see, Meinhardt Solutions, and what is it, LLC 2023 revision 2.2. So that is what we have here. Hope you can find it on the web if you are interested in. Okay, so ready to go. So only 4 screws left, which needs to get in. So battery is in. Let's check if it is working. Okay, so that is definitely a good sign. It is working, but that is what we had before. So what we want to know is if the battery will charge, and what we want to know is if the radio is now running on an external power supply, which was not given with the fault. So okay, let's switch it off, and okay, let me switch on our power supply, and now let me connect here the power cable, and let's connect it to our power supply. Let's plug the positive one, and hey, here we are. So it is charging. That is good. Once again, let me pull the connector, and you see the charging LED is off, and once again let it put back in, and you see it is charging, and that is what we had not before. Okay, and it is charging with 600 milliamps, which is telling me that it is really filling here. You can see it there, 582 now, and it is going down, so that is normal. So that means we have the charging process running. So now let me see when we switch it on if it is then on our power supply and not still on batteries. So let's see what's coming up. And yes, so what we can see there, our little icon, you can easily see that it is indicating our external power supply. And when I'm gonna pull it like so, you see it is directly going back to the battery. And when I now plug it in back again, you see now it is running on external power supply. So that means our repair was successful. And that means, on the other hand, we are at the end of our video. Thanks for watching, and catch you next time. Bye.